The Chapter 10 Slidecast will cover sorting. The objectives are to learn how to use the standard sorting functions in algorithm.h. And here's a large number of sorting algorithms that we're going to learn about. We're going to understand the differences in how these perform and which ones to use for small, medium, and large arrays. Sorting entails arranging data in increasing or decreasing order. And familiarity with sorting algorithms is an important programming skill. Now, the study of sorting algorithms gives us insight into problem-solving techniques such as divide and conquer, and analysis and comparison of algorithms which perform the same task. So the standard C library has two sorting functions, and each function uses a pair of random access iterators. And here are the C++ sort of template function declarations for a sort function that takes a first and last random iterator, another one that takes a first and last, and a comparison function. So each function uses a pair of random access iterators, and the first iterator references the first element of the sequence, and the second iterator references one past the last element in the sequence. Now, because these functions require random access iterators, they can be used only with vectors, decks, and ordinary C pointers. List container supports only bidirectional iterators, so it provides its own sort member function. There are two functions named stable sort. They're similar to sort functions. The primary difference is that elements that are equal may not retain their relative ordering when sort is used, but they will retain their relative ordering when stable sort is used. So if there's two occurrences of an item, the one that is first in the unsorted array is guaranteed to be first in the sorted array only if you use the stable sort version. Now, the sort function is slightly faster than stable sort, so you should use it whenever the relative ordering of the elements is unimportant. Now, the actual type of random access iterator passed to the sort function depends on whether we're sorting in an array, a vector, or a deck. The compiler attempts to match the actual types of the arguments to the template parameters, and if we use the second version of the function sort, you can pass in this comparison function. Now, if array items are stored as a collection of 16 integers, this sort statement will sort the array. The sort statement here sorts only the first half of the array, leaves the rest untouched. Here's a function called sorts the array in descending order using this greater function, which implements the comparison operator for integers. The following statements sort the elements of a vector v and a deck d. So we sort using begin and end iterators for both. Now, the following statement shows how to sort the elements in a vector in decreasing order by using the comparison function greater. On section 9.2, we had a compare function that we wrote, compare person. And remember, the person consisted of a family name and a given name, so the custom compare person function would first compare the surnames, and if the P1 family name was less than P2 family name, then person P1 would be considered less than person P2. If the family names were the same, then you'd go compare the given names. Now, if people list is a vector of persons, then here's a sort statement that would place them in order according to this compare person function. Now, the client program must include the file people.h, which defines the class person and this struct compare person. And that brings us to the end of this slidecast.